Hello everyone, welcome to Electron. We'll be doing cross-field and J.J Thompson's experiment. So for cross-field, it is a condition in which, well, let's say there is an electric field as well as magnetic field. So here, this is the electron moving in a straight line, and this, let's say, plus minus. If the electric field is stronger than magnetic field, then it tends to move up. If magnetic field is stronger, it tends to move it down. But in the exact position in which their two fields or forces are equal, then it goes undeflected. This is known as cross field condition. So for this to happen, the electric field, the force experienced by electric field must be equal to the Lorentz force experienced by magnetic field. So this is just E equals to, well, this is E V B. The electrons cancel. Therefore, the velocity of the electron is the, well, electric field by the magnetic field. This is just cross field, very short. Now time for J.J Thompson's experiment. Now J.J Thompson's experiment was to find the specific charge of an electron, and a specific charge is defined by its charge by mass. You can also use this to find it for proton as well. So his experiment or his figure was this. Now here his theory isn't that bad. By that I mean, like, the theory is very understandable and the mathematical part is very short. Now this is the low tension battery which connects to the filament cathode. And if there is cathode, there also must be, well, an anode, right? This is the anode, and here is a hole, which I'll explain why there's a hole later. So this anode is connected to high tension battery. So here we have low tension battery and high tension battery. And this is connected to the positive charge, negative charge. And due to this high tension battery, there is a potential difference called V naught. And here the point of cathode is, well, when a light the low tension battery heats up the cathode, thus the electrons emerge from the cathode. And here the point of the high tension battery, when it is applied between the anode and hole, well, this anode is positively charged. So here the electrons gain acceleration. The point of high tension battery is to give acceleration to the electrons, and the point of the low tension battery is to emerge the electrons in the first place. So here, due to this positive charge, the electron will get attracted, right? But it will move upward. But we don't want it to move upward. We want it to move, well, in a straight line. So this is where the hole comes in, which is charged with positive charge equal to that of anode. So what happens is the, well, electron goes undeflected, at the same time gaining kinetic energy with velocity v, just as it passes through the hole. Now here it just goes on here, and here there is electric field. This is positive charge, this is negative charge, with, well, electric field E with potential V, and this is distance between the plates. Let's say this is D, right? So here it goes like this, and due to the positive charge, well, it goes deflected like this, let's say at a point S1. Now here, let's say a magnetic field is applied on it. Then if a magnetic field is applied on it, then it will deviate downwards like this at a point S2. Now this is where a cross field condition comes in. At cross field condition, it goes undeflected and moves in a straight line to S. So here, this is the distance between the plate. That means that E will be equals to V by D. And here, due to everything going on in this apparatus, in this experiment, here the potential energy stored of this electron at any given point will be converted into, well, not converted, will be equal to the kinetic energy of the electron. That means it will gain kinetic energy equal to that of the, well, the potential energy gained by it at any given time. So here the potential energy is equals to EV naught. Because this is due to the high tension battery, it gets the potential energy. And the kinetic energy is of course 1 by 2 mv square. Now since these two are equal, then EV naught is equals to 1 by 2 mv square, giving us E by m is equals to v square by 2v naught. Now here we have already gotten specific charge that we need to determine. Now let's say it is very difficult to calculate the velocity, so what can we do? Now here we have, well, cross field condition, right? So in cross field condition, as I talked earlier, V is equals to, well, electric field by magnetic field, and here electric field equals to V by D, so V by dB. Don't confuse dB as change in B. And here what we do is simply put the value of V in this equation, therefore getting E by m is equals to V square D square B square into 1 by 2V naught. And from here we can calculate the, or from the right hand side we can find out what the specific charge is. But in a short time for exam, you can just directly do E by m because it is stored in your calculator, and the value of E by m will be 1.76 into 10 power 11 charge per kg. This is all for J.J Thompson's experiment, and if you learned something new, please like and subscribe. Thank you.